Welcome to Algebra 2, Module 3, Unit 9, Lesson 7, Change of Base. That's what we're going to cover here. So we're going to come up with the change of base formula here. And the purpose I basically go through is if I get something like log base 2 of x, we can use log of x actually to figure that out, because you're used to base 10, what we've been doing so far. So we're now going to shift that and get any other kind of base besides 10. And show you how to do this. So, I'll give you an example. Let's just say we want to find log base 2 of x, okay? And I set it equal to L, an unknown. So, and I said show basically that L is the log of x divided by log of 2. Well, it's pretty straightforward. If you remember, we take 2 right here, the base, raise it to the L like this, and that equals the x on the other side. Okay. Then what we do is we take the log of both sides. If I take the log of both sides, well, if I take the log of both sides, remember you got to take the L and put it out in front. So it's L times the log of 2 is equal to log of x. And all I have to do then is quickly divide by log of 2, and you got log of x divided by log of 2, and you've proven it. Okay. Now, we use the log of base 2 here, but it can be any log of base. So if I have a log of base b of x, that's going to be equal to the log of x over the log of b. And that's your general formula. Technically, you're supposed to put that in parentheses, okay? That's the change of base formula that we're going to work with here. This part's going to go through and show you basically the same thing. They're going to go through the proof. Instead of log of 2, they use log of base b and go through the same proof, get to the same point here, and give us this nice change of base formula. So star that up so you make sure you know that. But I just gave that to you on the previous page. And yes, there are things where a and b, unfortunately, I just covered them up, can't be equal to 1. And there's reasons for that, which we can get into later. All right, our next part here says to basically find the log of the 4 decimal spots. Use the log key on your calculator of these. And so I could do log of 3 squared. I also could do it as log of what is 3 squared? 9. Or I could take the 2 and put it out in front, and I could do 2 times the log of 3. Either way, these two answers, both, if you punch them in the calculator, come out to be the same, of 0.9542 when you go out 4 decimal spots and round off. And this one's the same, so that'll be the same answer, so same. Okay. The next one here has a log base 3. Now remember, we got a new rule that to change a base, so this is the log of 3 squared again, which is 9, but it's over the log of 3. So remember, go back to your change of base rule. Okay? And if I do the math here, and you actually figure this out, it will actually come out to be the whole number 2. Okay, using the calculator. Remember, close those parentheses. If you don't close them on this one, you're going to do the log of 9 and divide it by 3, and it's not going to be the same thing as this. You need the log of 9, close the parentheses, divided by the log of 3. The last parentheses you don't have to close. You'll still get through. Try the next one real quick and then check your answer with me. Okay, you should have what I did, which is take the log of that 3 squared, which is 9, and divide it by log of 2, and on your calculator you'll get 3.1699. Okay, and that's easy. Calculator does a nice piece for you. Many ways of doing this. There's more than just that. All right, on this part, it's all calculator. So I want you on number 4 just to do the natural log. It's right below the log key on the left side on your calculator. So do all those individually and just take a look at it and see what you can surmise from it. All right, so hopefully you punch those in the calculator. You can check your answers. Pause the video just to make sure you got them all right. No big there. Now we're going to move on to the next two there. We got ln natural log of 3 squared. So instead of log, we're doing that. So you know already that's the same thing as the natural log of 9. But it is not going to give you the same answer. The answer this time should come out to be 2.1972. So 2.1972. I suggest pause the video again real quick and do this next one, the natural log of 2 to the 4th power. So, that one turned out to be the natural log of 16, 2 to the 4th power 16. Once again, keep in mind, it could be, you could do it another way and say, hey, it's 4 times the natural log of 2, and you will either way get the same answer of 2.7726. Alright, so that's calculator work. Now we're going to get into a little more theory on how to break these up, and we got to know how to use the rules. Alright, so in this one here, I'm not going to touch the natural log of 4 yet. I'll leave that alone. But we got a subtraction symbol right there. And if you remember, subtraction is division in a sense. Or I can change it to a plus sign, and I have to flip the thing inside. So this would be 3 times the natural log of 3. And then plus the natural log of 2. Well, with the rules here, remember, you can put the 3 up front as an exponent, so that would be the natural log of 4. This is doing it the long way. You can do it quicker if you want. Plus the natural log of 3 to the 3rd power. Plus the natural log of 2. And remember, when you got adding, the same thing as multiplying. We can do the natural log of 4 times 3 cubed is, what is it, 3 times 3 is 9, 81, 27, times 2. So it's the same thing as the natural log of 216. Our job was just to rewrite as a single one. You could bust that up and tell me another way. That's a great answer. There's nothing wrong with that. You could recognize that, hey, that's the same thing as the natural log of 6 to the 3rd power, 6 cubed. Or you could give an answer of, put the 3 out in front, 3 natural log of 6. All 3 answers are A-OK. Now, you're also welcome to do a shortcut on that one. Like this one here, I could do, hey, it's the natural log of 5 times 32. Remember, this goes up on top, so raised to the 3/5 power. And then the minus 4 here, the minus sign, and we can flip the 4, so times a 1/4. And then I don't have to write out all the pieces like I did there. Now, some of you guys are going to need a little help with that 32 to the 3/5 power. Remember, 32 to the 3/5 power is really 32 raised to the 3rd power, and it's the 5th root. Well, the 5th root of 32, keep in mind, remember, is 2 times 2 times 2 times 2 times 2. So that's really a 5. So it's 5 to the 3rd power. So what's going to come out of this is really a 5 to the 3rd power. So it's the natural log of 5 times, no, actually, I'm saying 5 to the 3rd power. It's 2 to the 3rd power times 1/4, because it's 5 2s. Alright, so that's the natural log of 5 times 8. 2 times 2 times 2 is 8, times 1/4. Well, 1/4 and 8 cancels and gets a 2, so you get the natural log of 10. And that's how you write it, as a single piece. Alright? But there are many other ways of doing it, so don't be afraid to do it like my longer extended way. I got a shortcut there. Any which way is fine. Alright, 2 last problems before we summarize this. It says write this each expression as the sum or difference of constants, logarithms, and simple terms. So we know division is difference. It's subtraction. So you would do the natural log of the cube root of square root of 5x cubed, and then subtract the natural log of e squared. And we can start working on this and breaking this up. Now, since this is multiplication in here, I can write it as the natural log of 5 to the 1/2 power plus the natural log of x cubed to the 1/2 power, so it's 3/2 then. And then minus, if you want, 2 times the natural log of E if you want to put the 2 out in front. And then finally, I can rewrite it and put the half out in front. So I got half natural log of 5 plus 3 halves natural log of x. And then remember, the natural log of e is equal to 1. So what's 2 times 1? 2. So minus 2. So there's my answer. Ugly, but it is cleaning it up as much as you can, simpler at this moment. That's as far as you know. The last one, we're not going to get that far either. We're going to basically split it up. We got the natural log of an x plus y squared minus the natural log of x squared plus y squared. So natural log L of n. Okay? The only thing I can do to clean this up is put that 2 out in front. So it's 2 times the natural log of x plus y. And then minus, and I can't really do anything else with the other one, natural log of x squared plus y squared. And we're going to just leave the answer just like that. Okay? All right, time to summarize. So we have established our change of base formula right here. That's the key. There's your formula. If you have the change of base, anything you've got, log of whatever the base b is of x, put the log of whatever it is of x over the log of b. And we have a formula to change logarithms into natural logarithms, so L of n. And when we're talking about that, here's what you've got. Start off with it, and it can be changed into consistent natural log of x over the natural log of b. So we're going to do a bunch of problems